This is lesson 11, practice problem number 1. And in this problem you have 4 pairs of points. And for each of the pairs of points you're supposed to figure out the slope for a line that is drawn between those 2 points. So for each one I graph them on this grid paper, this graph paper. And so you can check your answer. I'm going to show you mathematically in a moment how to do this, but you can check your answers just simply by counting. So the slope is the ratio of the vertical length. So this is 1, 2, 3, 4 to the horizontal length. 1, 2, 3, 4, 5, 6. So that relationship is 4 units to 6 units, or 2/3, 2 to 3. So for every unit that you travel along the x-axis or in the horizontal direction, you go up 2/3 of a unit. So that point right there is 2/3 of this unit right here. So the slope is 2/3 or 4/6. So to figure it out mathematically, if you look at this line and you figure out the vertical distance, it's at 0.7. I'm sorry, it's at 0.5. The y value is 5, but to get this length, which is 4 units, you have to subtract this 1 unit that it's been moved up. So it's been moved up 1 unit from 0, 0. So to figure out this length, it's not 5 units. It's that 5 units minus this 1 unit. So whatever the value for y is, you have to subtract the 1 unit. And in this case, that's 5 minus 1 equals 4. So the vertical length is 4 units, and the expression for that, the algebraic expression for that, is y minus 1. So whatever value you have for y, take 1 away. You have to take this 1 unit away. Likewise, for the x value, you have to take this 1 unit away to move this triangle over to the y-axis. So basically what you're doing is taking this triangle and moving it to 0, 0 to get the values of y and the values of x to tell you the lengths. Well, this length along the horizontal axis is 6 units, 1, 2, 3, 4, 5, 6, but the x value is 7. Well, it's not 6, it's 7, but to get to 6, you have to subtract this 1 unit. So the horizontal length is whatever the x value is minus this 1 unit. In this case, it's 7 minus 1 equals 6. So the slope is the ratio of those two values or expressions. So it's the y value, which is the vertical length, which is along the y-axis. It's the y value minus 1 compared to the horizontal length, which is the x value minus 1. So the slope is y minus 1 over x minus 1. It's that ratio. Now we know what it equals. We know it equals 2/3. We know that it equals 4 units along the y-axis, 6 units along the x-axis. So that's a ratio of 4 to 6, which equals 2/3. So that allows you to write the equation. So the relationship of y minus 1 to x minus 1 is 2/3. So you can write that as an equation. The vertical length is 2/3 the horizontal length. So that's what this is in words. So whatever the vertical length is that you're given, that vertical length is going to be 2/3 of the horizontal length that goes with that is part of the same slope triangle. So the equation is the value of whatever the value of y is, in this case 5, minus 1, compared to the value of x minus 1. So it is that relationship that gives you the length in the y direction compared to the length in the horizontal direction. In this case, it's 2/3. So this is the equation. It doesn't ask you to write the equation, but that's what this lesson is about. So this is good practice. Okay, the next one, go a little bit faster on this one. So in each case, again, you're going to take this 1 unit away from the x coordinate, the x value, and this 1 unit away from the y coordinate or the y value to calculate what each of these lengths are. So this length, this horizontal length in this case is 7 units. Well, what's 7 minus 1? This length is going to be 6. You have to take away that 1 unit right there. So 7 minus 1 is 6, and you can check it. 1, 2, 3, 4, 5, 6. And 5 minus 1, again, you have to take away that 1 unit right there to figure out this length. So 5 minus this 1 gives you a length of 4 units. 1, 2, 3, 4. So the relationship along the x-axis, the horizontal length, is x minus 1. This is the same as before. This is y minus 1. It's the same as the last problem, but their relationship is different. In the last problem, it was 2/3. In this problem, it's not 2/3, it's 3/2. So it actually is the reciprocal because they've reversed the x value and the y value. So that relationship, the distance along the y-axis is 6 units. The distance along the x-axis is 4 units. 6/4 is the same as 3/2. So whatever value you're given as x, the y value is going to be 3/2 of that. So it's going to be 1/2, 2/2. It's going to be 1 unit equal to the x along the x-axis, but then another half unit. So this is 1/2, 2/2. And so these extra 2 units here are going to be the 3/2. So the equation in words, the vertical length is 3/2 the horizontal length. So whatever the vertical length is, whatever the horizontal length is, the vertical length is 3/2 of that horizontal length. So the equation looks like this. It's the same, the left side is the same as the last problem, y minus 1 over x minus 1. Why is this y minus 1? And why is this x minus 1? Because you have to remove these single units right here. And what's that equal to? This has a relationship of 3 units to 2 units. It starts out as 6 units to 4 units, but then you can write the equivalent ratio as 3 units to 2 units. The next problem is a little bit trickier because now you have a negative value. So if you want to calculate what the length is along the horizontal axis, instead of subtracting, now you have to add. You have to add this 1 unit to whatever that x value is to get this length. In this case, it's 3 units. Well, this point is at 2 units, 1, 2, but then I have to add this 1 value to get this length. So this is going to be x plus 1. And the y value, I have to subtract these 2 units. So it's like moving this triangle over 1 unit and then sliding it down 2 units to get it to 0, 0. So this 5, 1, 2, 3, 4, 5, to calculate this length, 5 minus these 2 units. So whatever the y value is, you have to subtract these 2. So you have to add the 1 unit here and subtract the 2 units here. So the length of along the horizontal axis is x plus 1. In this case, this is an x value of 2. So that length is going to be 2 plus this 1 unit equals 3. And the y value is going to be whatever the length along the y-axis is going to be whatever the y value is minus these 2 units. So that's 5 minus these 2 equals 3. So what's this ratio? What's the relationship of the length along the y-axis compared to the horizontal length? So the vertical length compared to the horizontal length is 3 to 3 or 1 to 1. So the slope is 1. So for every unit you move along the horizontal axis, you move along the vertical, whatever you move in the horizontal direction, you move that same number of units in the vertical direction. So 1 unit to the right, 1 unit up, 2 units, 2 units up, 3 units long, 3 units to the right, 3 units up. So the slope now, in this case, the relationship is y minus 2. Why is that minus 2? Because you have to get rid of these 2 units. And x plus 1, you have to add this 1 unit. So 5 minus 2, that 5 minus this 2 actually, and that's 2 plus 1. So it's 2 plus this 1. Now notice this is negative 1 here, so we're going to get to that in just a moment. And so you figure that out. This is 3 divided by 3, so you get a slope of 1. Now, x plus 1 is the same, going back to 7th grade, as x minus a negative 1. So in this case, what's the difference between the value of x and negative 1? So how far are they apart? Well, the difference between 2 and negative 1 is 2 minus a negative 1. So what's the difference between them? It is 3 units. So the way that you can calculate that is use the inverse operation and the additive inverse. So the inverse operation is addition. The additive inverse is a positive 1. So this is x plus 1. So a little review from 7th grade. We'll go into that more. You're going to have to use that more. So the vertical length is equal to the horizontal length in this problem. So the vertical length, so whatever horizontal length you're given, the vertical length is going to be the same. So the equation looks like this. So y minus 2, got to get rid of that 2 units. X plus 1, you have to add that 1 unit. Remember, it's really x minus a negative 1, but that can be written as x plus 1. So what does it equal? It equals a slope of 1. Okay, and the last problem. Now, this one is a little bit more complicated because now you're pretty far over and both of these are negative. So to figure out the length along the x-axis, the horizontal length, you have to add these 7 units. This length is actually 9 units long. You have to add these 7 units. 1, 2, 3, 4, 5, 6, 7. So whatever value you're given as the x coordinate, the x value, you have to add 7 units to it to get it back to the y-axis. Likewise, whatever value you're given for the y coordinate, to figure out the vertical length, you have to add 4 units because you have to slide this up these 4 units. So 5 plus 4 and 2 plus 7. So 2 plus the 7 units to move the triangle, the slope triangle to here, and 5 plus 4 units to move the slope triangle up to here. So 5 plus 4 is 9, and this vertical length is 9 units. You just count to check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the y coordinate is 5, and you have to add these 4 units. And the x coordinate, or the length along the horizontal axis, is also 9 units. It's 2 units from the x coordinate. Then you have to add 7 units. You have to slide this over 7 units to get this length, which is equal to 9 units. So it's that 2 plus these 7 equals a total length of 9. And what does that equal? It's 9 divided by 9, so that gives you a slope of 1. So if you look at the slope of this line, you're going to notice you move 1 unit in the horizontal direction, you move 1 unit in the vertical direction. 2 units, 2 units, 3 units, 3 units, 4 units, 4 units, and over here where this point is, it's 9 units, 9 units. So that has a slope of 1. So there's the equation, y plus, or the left side of the equation, y plus 4, why am I adding 4? Because I need to move this value up these 4 units, and x plus 7, I have to move this value over these 7 units. And what does that equal? What's the slope? That equals 1. So this is an equation for this line. We're going to get more into that. And remember that it's really 2 minus a negative 7. So it's 2 right here minus this negative 7 is the same. You can use the inverse operation and the additive inverse. It's really the same as 2 plus 7. And this is 5 minus negative 4. Use the inverse operation, which is addition, and use the additive inverse, which is plus 4. If you're going to use the inverse operation, you then have to use the additive inverse. If you're going to change one, then you have to change the other. So y plus 4 and x plus 7. And here it is all together. And that's a lot. You guys are now doing a whole bunch of stuff, figuring out equations for lines. And we're going to use this to solve problems in the future. The next problem is problem number 3. In this case, you are given this line, and you're asked, what are the coordinates of B and what are the coordinates of D? Well, the coordinates of B, notice this goes through this slope triangle right here, goes right through this point 0, 0. So the coordinates of B are 4, 0. So this length is going to be 4 units long. It's going to be the value of x. And what are the coordinates of D? Well, it's twice as far out. So it's along the x-axis is 8 units, but then along the y-axis it is 10 units. So now they're going to ask you some information about other units, but let's look at this in a little bit more detail. The horizontal length is x because this slope triangle goes through 0, 0, so you don't have to move it at all. So the horizontal value is x, and the vertical length is the value of y. So this vertical length here is 10 units. That is the y-coordinate is 10. That also tells you that the vertical length is 10. Because you don't have to move this triangle at all. It goes through 0, 0. So you can just take these coordinates to get the slope. So the vertical length is 10 units, which is the y value, and the horizontal length is 8 units, which is the x value. So to get the slope, it's just the vertical length, which is y, divided by the horizontal length, which is x, which is equal to 10 over 8, or 10 to 8. And that's the same as 5 to 4. So for every 4 units that you move in the horizontal direction, you move 1/4 more of the horizontal length in the vertical direction. So 1/4 of 4 is 1 unit. So the vertical length is going to be 5 units, 1/4 more. For this 8, you're going to move in the horizontal direction 8 units. The vertical direction is going to be 1/4 of 8 more. Well, 1/4 of 8 is 2 units. So you go up to 8 units, and then you add 1/4 of 8 more. So that's the 5/4, 1/4 more than 4/4. So that gets you to 10. So this relationship is 10 to 8, 5 to 4. So y is 5/4 of x. This is the relationship in words more. Y is 1/4 of x greater than x. So y is 1/4 of x. X is 4. 1/4 of x is 1. So y is 1/4 of x greater than x. X is 4. 1/4 of 4 is 1. So y is 1/4 greater than that, which is going to be 5 units. 1/4 of 4 greater equals 1 unit, gives you a length of 5. This 1 unit right here is 1/4 of the horizontal length. All right, so here's actually the equation, the relationship. Y is equal to 5/4 of whatever value x you're given. So if you're given a value of 4, 5/4 of 4 is 5. If you're given a value of 10, 5/4 of 10 is 8. If you're given a value of 8, if you're given a value of 8, 5/4 of 8 is 10. So you have to figure out the y value. All right, I hope that I said that correct back here, but anyway. Whatever x is, y is 5/4 of that value. So if x is 4, y is 5. 5/4 of 4 is 5. If x is 8, y is 10. 5/4 of 8 is 10. All right, so we can use that to check the points that they give you in the problem. So they ask the question, is the point 16, 20 So an x value of 16, a y value of 20, is that on the line? Well, what's the ratio of 16 to 20? 20 is 1/4 of 16 greater than 16. So what's 1/4 of 16 is 4. 16 plus 4 is equal to 20. So yes, this point is on that line. So whatever value for x you're given, y is 1/4 greater than that. So it's 5/4 of 16 is 20. 20 sixteenths. 5/4 of 16. Divide by 4 in each case equals 5/4. So 16, the point 1620 is on the line. What about 2024? Well, 24 to 20 gives you a ratio of 12 to 10, which is the same equivalent ratio as 6 to 5. Well, that's different than 5 to 4. So this point is not on the line. So if you graphed it, I'm actually 20 units out in the x direction and 25 units in the y direction. So just 1 unit more would be on the line. So this is just 1 unit short of that. The reason I can say that is 25 is 1/4 greater, 1/4 of 20 greater than 20. And these are hard things to talk about, to think through. You just have to put pencil to paper and practice it. What about 180, x value of 80 and a y value of 100? Well, that ratio is 180, which is the same as 10 to 8. Just divide both of these by 10, which is the same as 5/4. We had 10 to 8 before, so a ratio of 5 to 4. So yes, that is on the line. This is what it all looks like all together. So again, you're getting into some pretty complicated stuff here. All right, the next problem. I have 2 students. One student uses this triangle and says the slope is 1 5/10. Another student uses this triangle and says the slope is 6 to 4. So which one of the students is correct? Do you agree with either one? Disagree with both? Agree with both? So first of all, you can show that these triangles are similar. We've done that many times by now. You can just take this triangle, small triangle, and translate it up to this triangle. So we know that both of these triangles are similar, and we knew that in the first place already because this angle is congruent to this angle, and they both have 90-degree angles. You only need 2 congruent angles to show that 2 triangles are similar. Reason for that, once again, is it forces this third angle to add to 180 degrees. So the third angle also has to be congruent. All right, so this has a ratio of 3/2 to 1. So this is the length along the x-axis. The horizontal length is 1 unit. The vertical length is 3/2. So this is 1/2, 2/2, 3/2. 3/2 is the same as 1 5/10. And this larger triangle has a slope, a vertical length of 6 compared to the horizontal length of 4. So 3/2 to 1. If you multiply these both by 2, that's going to get rid of this half. That's going to give you 3 to 2, which 3/2 is the same as 1 5/10. And 3/2 is also the same as 6/4. If you double the 3, you get to 6. And if you double the 2, you get to 4. So both students are correct. The slope of 1 5/10 is the same as the slope of 3/2 is the same as the slope of 6/4. So both students are correct. And the last problem, you're given a rectangle that has a length of 6 units and a height of 4 units. So 6 by 4. And you're asked to look at each of these statements and identify the statements that show that they cannot be similar. So the rectangle described cannot be similar to this rectangle. So I label this A prime, B prime, C prime, D prime because the rectangle they give you in the problem is labeled A, B, C, D. That's the unknown, they call it quadrilateral in the problem. All right, so if you have AB equal to BC, can you have that and have a similar rectangle to this? Well, you cannot. AB has a length of 6 units, BC has a length of 4 units, so they are not equal to each other. So if you have them equal to each other in some other quadrilateral, some other rectangle, actually it would be a square if they're 90 degrees. So anyway, A cannot be similar. B, what if you have a measure of angle ABC? So this angle right here, ABC, is equal to 105 degrees. Well, in a rectangle, all the angles measure 90 degrees, so that cannot be similar. How about C? Can you have a length equal to 8 units and be similar to this rectangle? Well, yeah, you can. BC would then be 2/3 of 8. Notice that BC is 2/3 of 6. So if you have a length, if this length were 8, then BC would be 2/3 of 8. Well, 2/3 of 8 is equal to 5 1/3. So this length would be 5 1/3 units. So that one is okay, that one works. What about D? What if you had a length BC of 8 units? So the height was 8 units. Well, the width is going to be 3/2 of that. So notice that the length. The length is 3/2 the height. So 6 is 3/2 of 4. 4 is 1/2, 2/2. 6 is 3/2. 1/2, 2/2, 3/2. So if this length were 8, it's just double the length. Then this length is going to be double. This length is going to be 12. So 3/2 of 8 is equal to 12. What about taking the length BC? Is that equal to 2 times the length AB? Well, it's not. 2 times the length BC is not equal to 2 times AB. 2 times AB is 12. BC is 4. So that would not work. And finally, the last one, if you double AB, 2 times 6 is 12, and you triple BC, 3 times 4 is 12. Does that work? And it does work. 12 is equal to 12. So if you double AB and triple BC, you're going to get, you can get a quadrilateral that is similar. So the answers are A, B, and E. Those quadrilaterals are not similar. So these are the practice problems for lesson 11.